Cool. So let's get started. So for those of you who are in the audience, hello everyone. This is the first episode of a podcast series that we are doing called Usable ZK. Zero knowledge cryptography has long fascinated researchers, with the original paper, coming out in 1985. But only recently has the engineering caught up to make the technology available for practical use. Right. So this is a series that we've just kicked off to explore the frontiers of technology, of cryptography in general, and zero knowledge proofs in particular, with some of the top brains in this space. And talking of top brains, today we have Kostas from Sui. Kostas is the lead cryptographer and co-founder of Sui. And as you all know, Sui is a high throughput non-EVM blockchain. So there's a lot of interesting research going on Sui's side. And before building Sui, of course, Kostas was the lead of all the blockchain endeavors at Facebook. I'm Madhavan, co-founder of Reclaim Protocol, and I'm going to be your host. I have a list of questions that I have ready for Kostas, and we are going to be doing some hard hitting today. Kostas, first of all, welcome to this show, and super excited to have you here.
Yeah, my pleasure as well to join you on this one. As I told you at the very beginning, I'm a huge fan of the work you're doing. And as you know, we have at least one employee who has worked on this topic from the very, very beginning. And now seeing this stuff being in production actually makes me excited. Zero knowledge proofs at the very beginning was only pretty much on the blockchain space. I believe you're adding like a new element of let's go to the real life and connect the two worlds. So yeah, my pleasure as well to join you on this one. And yeah, open for any questions, even the difficult, the juicy ones, whatever you want to hear from me.
Awesome. I think that's a good point that you touched on. Just want to give a shout out to Deepak as well. Deepak, of course, works closely with Kostas, and his work around Deco kind of inspired a lot of work in the ZKTls space. So a quick shout out to Deepak, even though he's not really here right now. But yeah, awesome. So Kostas, let's start with all the hard questions. So first of all, if you could set up the context of how you started building Sui, primarily from the lens of like when you started building this, not just at Sui, probably also at Facebook. Now you had to probably take a few assumptions that were being made by the blockchain industry at large. Like a lot of people were building blockchains even back then, but there were a few assumptions that you probably took and say, hey, you know what, these assumptions don't really make sense. And debunking those assumptions gave you a richer design space to work with, which eventually led to a new design for building blockchains, which now has manifested in the form of Sui. So can you take us back to that time of what were the assumptions that you debunked? What was that process, and what were the core assumptions that you made that were different from the other blockchains back in the day?
Of course. By the way, it doesn't mean that I'm aligned completely with what Facebook was trying to do. However, I will give like a short background of myself and why I ended up at Facebook personally, like as a researcher. So even before I joined Facebook, I was also in the blockchain space, and I actually worked with one of the first developers of Satoshi. Some of you might know him from the early ages. He also created Bitcoin J. His name is Mike Harn, and Mike Harn hired me to work on a like slightly more permissioned blockchain back then. And it was like a coalition, I would say, between multiple banks and insurance companies, even like vehicle, whatever you can imagine from the traditional world, that they wanted to build something else compared to Bitcoin and Ethereum, mostly to have fast settlement between banking transactions, and eventually, gradually, they would open it to the real world. So it was something between permissioned and permissionless network. This gave me actually knowledge on all of the things that happened at the Bitcoin in the past. I used to be a white hat hacker for Ethereum. This is the first point we have to actually highlight here, because if I didn't know the problems that Ethereum and Solidity have, probably I wouldn't even jump to Facebook. And then I will explain why this was important for my personal decision here. So back then we decided to build, before I joined Facebook, something with Java and Kotlin. And then I realized, now I see that it's not only one language that eventually can win. It's pretty much every language has some probability to have some success, because we've seen it on the regular programming, right? We've seen C, then Java won for a few years, then again back to C++. Then we have Go, then we have TypeScript, JavaScript. Eventually there is not only one language solving all of the problems. And then I was considering, okay, So Solidity is a new language, very primitive language, closer to like scripting language, I would say. Obviously, as the first language who is offering smart contracts will have its own like problems and maybe vulnerabilities. And I was able to work, like I was literally making money because I could find vulnerabilities in smart contracts from other companies. I was applying this stuff to a new blockchain. As I told you, it was called Corda back then before I joined Facebook. And then one day, after 2 or 3 years in this company, I used to live in London back then. Then Facebook comes to me, Sam, our CTO, and he tells me, look, Kostas, I know you're working on this stuff. We met together in a Canadian conference about blockchains. I was presenting back then some post-quantum cryptography, how we can like protect the blockchains when the quantum computers come to life. And Sam told me, we're building something very cool. I knew, of course, about the Libra project, and we're going to create a new language. And obviously they knew that I was also very active on the hacking community, and I knew the problems of Ethereum. And obviously having Facebook creating the Move language, which is now the flagship of the Sui blockchain and some other blockchains these days, I said, okay, obviously it's a great opportunity. It also gives me access, the second point now, to billions of users. Imagine as a cryptographer and typically having to do with like smaller scale companies in Europe, because I was working in between European countries. I lived in Paris, I lived in Greece, I lived in Cyprus, I lived in the UK, in London, then eventually I came to the US. Being in such a big organization changed my mindset that the blockchains have now an opportunity to be the big thing, because if Facebook is investing on these things and Facebook has access to 2 billion users, now we have the opportunity. It's not just back then 500,000 Bitcoins that are playing with the blockchain. We can show this to the whole world. And this inspired me to go to Facebook. Like a new language, better than Solidity, faster than Solidity, and also access to the mass. Because as you can see with zero knowledge proofs now, we're trying to solve these problems as well. Before zero knowledge, everyone to create an account, they required all of these mnemonics, right? I mean, the average Instagram user and the average Facebook user cannot do that. So obviously I said, okay, I have an opportunity as a researcher to offer to have an impact to the blockchain community. And after this, Facebook managed to create like a very good team. In my opinion, probably the most expensive team in the Web3 space. I don't know how many millions Mark was spending on this effort, but it's like a lot of money. And then we had a huge team of probably some of the best researchers and engineers in the world working on a very big like blockchain. When we realized that Facebook was not able to launch it, for many reasons, from regulation to like it's a big organization, typically slower, Web3, you have to be very, very fast. We had the other issue as a researcher where I was implementing an algorithm every month. And then it was almost impossible to put it in practice because, if you're in a big organization, bureaucracy is very difficult to get you in a state where you can convince other teams to also have your algorithm. And this is where we said, even before the Libra collapse, myself, Evan, Sam, George Danezis, who is like the best researcher on consensus, in my opinion. He was literally on my PhD as a reference citation. And Adenigi, who is like the product genius here. And we left Facebook even before the collapse and we created Sui and we said, let's move fast. We have so many ideas and so many ideas that we packed in our brains that we are better than Ethereum, better than Solana, better than Bitcoin. Let's go and build something new. Plus innovation, right? Because if there was an innovation metric, I believe that at the moment, even in the history of the blockchain, I think if we're not the top, we're definitely in the top blockchains in the world regarding how many new innovations we're offering to the space. This inspires me, right? I mean, imagine as a researcher, I wanted to be in a place where I could make an impact even with new ideas. And this is why I'm here at the moment.
Wow, that is quite a journey. Thank you for all that color from your Cardo days all the way to where you're with Sui today. Hey, so I saw one of your slides in the presentation that you were making in one of the events where you were saying the KPI that matters for blockchains is the number of new algorithms invented per week. All right, so that was like super, super interesting and very motivating to see. I know it was almost kind of tongue-in-cheek kind of a KPI, but it was pretty thought-provoking. And then on that dimension, I want to also jump into the next question, which is probably very related, is you called something called internet-less, right? So, of course, Sui, everybody knows, is like one of the top blockchains when it comes to TPS. But the other interesting thing that you talked about is because of the kind of decision that Sui has made and the kind of architecture it has, internetless transactions might become possible. Can you talk to us about
Of
how
course.
internetless transactions can come to be on Sui, and what are the unique things about Sui that enables this?
Of course, of course. That's my baby, one of my other babies, by the way, in the Sui blockchain. So I can also go back to Facebook now and explain to you what we were planning to do. Facebook had situations where there was an outage, and for a few hours, many people couldn't actually access the internet. And it's not only outage, there were situations where the internet went down because of government decisions and other situations. And there was a project, I remember pretty much the second year that I was there, 2020 or 2021, early 2021, COVID days, where we wanted to have a solution even for remittances, where people who, due to COVID, who were staying at home, COVID actually, believe me, but scaled innovation in a sense that might be impossible to do it without having a real problem in our life. So we were trying to solve these problems even from then. However, we didn't have the capacity probably because, okay, imagine if you're launching a new product, they don't give you unlimited time to do your own work on the side. And I tried to solve the problem of remittances, right? And remittances was a problem where what if we want to give money to people who now are enclosed in their homes? They cannot even go out. They might not have internet. The infrastructure might not work and all of this stuff. People don't go to work, right? On the telephone operators and other things in some countries. How do you solve this problem? And then I realized, okay, let's assume that we didn't have internet today. There might be a solar flare or something that happens and there is a war or there is something. What do? There are a few options, right? One option is you replace the internet with a telephone communication. But then you will say, can you send things by SMS or telephone calls and all of this stuff? Well, you can. You can because if you are a very fast blockchain, your transactions are very short in a way that you can make with some cryptography, some compression here, because you only need in Sui, for example, where object-based, just get this object, remember it on your wallet, and you can now submit transactions. You are using very short signatures, so you can fit it probably in an SMS. I managed to have a POC where we are using full node, and the full node has an SMS endpoint. So if you are not having access to the internet, you can send a transaction by SMS. We do everything required to fit it in an SMS. Even if it's not fitted because it's a very complex transaction, you fit it to 2 SMSs, and we created a protocol. This protocol doesn't use the internet. It uses another channel now, a telephone-related channel, to be able to reach full nodes and validators. So what you need is some full nodes eventually to enable these APIs so people can connect to them. We build a POC for this. The second one is, okay, let's assume that there is no telephony, right? What do we do there? Okay, there are other signals as well in the world, and in some situations, there are waves where, helium is also doing that in some sense. But we say we're super fast as a blockchain. If there are all of these users that we're getting more users than other blockchains, maybe we can have more hops than others. And maybe you can use the LoRa channel or the radio channels to be able to submit transactions. And then we started working. I don't know if you've seen one of my recent tweets, small devices like Raspberry and Arduino devices to be able to be connected to your phone. And then if you don't have access to the internet, automatically, boom, you have a radio signal. You just need the hop in a few kilometers. And then after hop by hop, you just need one internet connection or SMS connection for your message to be received by a validator. And then we even said, okay, is this enough? Why can we do some cryptography here? And now I have an intern that we're working even on mini Lightning Network channels on Sui. You will see it probably end of Q3 or something. I cannot commit on this because it's an interesting project, but you will see situation where you can even pay Tesco, you can even pay like a big grocery store, even if you don't have internet access at all. And not even them having internet access. Imagine an earthquake, in a flood, what happened in Dubai very recently, you can still submit transactions with all of these protocols. And this is pretty much the spectrum of all of the ideas we have here. I even found a way you will see me this year, probably in Greece. I will use underwater sound signals to send messages from one island to the other, Sui transactions. So I'm doing many experiments, but you will see a set of applications. I call it like the Deepin framework, where with some POC and the community held, we will be able to have decentralized internet as well, right? Because even now, Bitcoin and Ethereum and all of the others are dependent on the telephone providers. Is it decentralized full? Maybe, but there is some power. Can we avoid it to have at least a backup channel? This is what I'm working on at the moment.
Wow, that is super, super ambitious, Kostas. Because I want to dive a little bit deeper into this internetless framework that you have. Is what are the design decisions that have been taken in Sui that makes this internetless thing possible on Sui and probably not possible on other blockchains? Is it something that's unique about Sui, or is it just about putting in the hours and figuring out a way to make this work on a blockchain in general? So, can you throw a little bit of light on that?
Of course, of course. I believe one aspect of Sui is we're having many world records on cryptography and then compression of cryptography, where you can use this to feed transactions to make transactions as small as possible. When you are having channels outside internet, the speeds are not great. So you need to find ways to actually bend the compression element of the transaction size. And we came up with some ideas where we can compress even the objects. I mean, we're object ID based, but if we know that there is no collision, maybe we can shorten the object by the time you're submitting the transaction. So you are signing the full object ID, but you are not sending the full object ID. You are only sending some information. And I'm coming to the AI world, where because now we have better AI and this was not possible in the past, we can even make predictions. How many bits should I send for the object to be able to reconstruct it at the full at the validator side or the full node side? And eventually I managed to compress, because you can just have a locked object for your basic transactions if you don't have internet, to very short amount of information. And the signatures that we're using, you can even just send, for example, just the signature, and the public key can be inferred. Ethereum is using this, but not all of the other blockchains are doing it. So we have this concept of agility in cryptography, and some of the algorithms are really fast and compressed enough to allow you to have shorter transaction size. This is one element, because you need it, right? If you go to a state where the speed of transactions, just because the network is not fast anymore, you don't have like 5G and satellite, blah, 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 then you need to compress. So Sui is very friendly on this, because we have all of the cryptography APIs where you can do stuff that is more expensive in other networks. The other thing you can do is we have zero knowledge proof APIs and other things where you can now compress even further, right? I mean, we're trying to solve the problem of making the transaction as short as possible. And cryptography itself, as I explained before with the mini Lightning networks, if you didn't have a few algorithms to even, for example, having a gambling game being played offline completely, zero RTT, and this is literally off-chain, we have the elements on Sui to be able to support better and faster. I'm not saying that nobody else can do it if someone spends some effort on making internet transactions elsewhere, and Bitcoin tried in the past, but I don't believe everyone tried to have like a holistic view. What do you do as a backup of the backup of the backup and compression? This is where I believe we're signing, like as a company. We have so many people who can think of very difficult problems, compression, new cryptographic primitives, even like protocols, systems that you can build on top of it to make the communication faster. We have the fast path, for example. You don't need to wait for a full consensus in Sui. So for transactions, very basic P2P transfers, minting, buying things from NFTs from others, we can actually have a protocol where you need less communication, right? And this eventually helps, right? It gives you an advantage. Everyone who can do it. There is helium at the moment, right? But they cannot reach the TPS that we have just because of some advancements in technology that we applied. So it's very simple. The innovation rate, again, was one of the factors that internetless is made better and faster to be implemented in Sui.
So that is super interesting. I know you just touched upon a little bit of AI, and I saw a tweet that was almost a teaser for me from you. So you had like a whiteboarding session, I believe, which was called AI plus crypto in March. What were some of the most interesting conversations, interesting ideas that came out of there? And a related second question is, where can cryptographers contribute in the advancement of AI itself? It's a two-part question. The first one is, what were the promising ideas in that whiteboarding session?
By the way, in this meeting, the head of AI of Mark Zuckerberg Foundation was there as well in Palo Alto. Like, we had so many big names in the headquarters of Sui, like of Mr. Labs, that you cannot imagine what was the green substance like in the air, right? You can feel it, that there were people who had so much knowledge on AI. I mean, obviously surpassing myself. I'm not an AI expert, although I used to be an algorithmic trader in the past. I used to build neural networks. It was insane. A few problems that we try actually to capture was actually use AI to improve blockchains, use blockchains to improve AI, use AI to profit from blockchains. And there are applications that can combine both, right? I mean, you might have something that has both like some blockchain elements and AI elements. The most interesting topics, in my opinion, that we covered was automatic audits using now AI tools for checking the smart contract security, even having a situation of continuous audits, because it's impossible to go every week for every update, to go to an auditor to make like some corrections, because it's not only the smart contract. You know, a few people are updating their web page. The smart contract itself might be updated rarely, but sometimes it's updated though. And there are situations where the platform is also updating itself, and maybe AI can help you to even make it faster or even make it more secure. This is a sector, I believe. And by the way, I personally found some crazy multi-million-dollar attacks. In other, obviously, I have NDAs and I cannot, like in this podcast, mention a lot of things. But even if I wasn't the co-founder, believe me, I could actually make a lot of money from bug bounties. AI for auditing and security is now a must. I don't believe there is any smart contract developer that even by the time they're publishing a smart contract, they don't pass it at least once from Gemini, ChatGPT, Llama, Claude, anything. It's a must. No, never do it. Even before you go to the auditor, just have a pass because it can give you some hints, right? And the auditor will not look for easy mistakes and they don't focus on the important stuff. The second thing that I realized is we can have verifiable AI on chain. This is very important. Imagine we are here and we have situation, even your protocol, Reclaim protocol, can eventually have AI on the output of ZK, where you can read the web page. This web page is also changing gradually, like every single time. Even if you don't update the ZK circuit, maybe you can have a verification of some AI protocol to understand that, oh, the SSN was there and now went there, but I'm not updating my circuit. The AI will tell me where it has been. And then you need, however, verification of this on chain. So ZK and AI will be like a huge thing, right? Eventually, we're going to have CryptoKitties where you are going to have a CryptoKitty that is evolved with some AI logic, but you need the verification, right? You cannot just get an output from ChatGPT. How do you know if a human actually put their hand and created a new feature in the new CryptoKitty that was generated that makes it special? You need to ensure that nobody could sit here. So we see that cryptography and AI, now we're getting there, and we have requirements of cryptographers to be involved into the evolution of AI for verification. The other thing that we also explored, and I'm sure it will happen, new algorithms will appear because we're going to use as researchers AI to help us improve the protocols. We can even have a situation where you're talking to AI and eventually you're starting with a basic protocol and might help you on creating the best, post-quantum cryptography just because AI gave you hints. It doesn't mean that ChatGPT or Gemini will give you the full protocol. But if you have experts, they can get these hints. And believe me, we will see like an immense amount of new ideas just because the researchers started using AI and they get rid of now checking all of the literature in the past or how do I implement this to see it in practice? It will happen automatically. In my opinion, these are the three major elements. Of course, there are many other things like trading optimization. For example, the wallets of the future, in my opinion, all of them will be smart. You don't need to do gas like optimization by yourself or the wallet. You will have AI. So this is the major part. And there is another very important thing that we can see how the blockchains can be used as marketplaces. That's the last one, where cryptography can be used for private sharing during the training of AI. This will happen at the larger scale between governments and companies who have like PII data and more information. You need to use a place where you know where the data is going. You can probably incentivize the users as well to not sell the data, but have with some privacy preserving way, their data being monetizable from now on. And I believe this will also be a place where some of our viewers here, like our listeners, will be able to form startups. And I'm sure some of them are already out there. But yeah, I can also help personally to give you some ideas on how you can create another unicorn.
Let's hear your top idea for what a unicorn could be in this space for any developer in the audience. I ask that specifically because most of our audience are young developers aspiring to build companies. So if you have like one or two ideas that some of these developers should focus on right now, which could be like unicorns, as you said, it would be super interesting to hear them out just to seed some ideas.
Nice. By the way, another thing that I personally realized that is happening, people are creating AI bots. They're making money from AI now. And It's easy, right? You can even have, I don't know, poker robots playing together on a blockchain state where we will see organizations and universities competing. Robots will be competing on the blockchain. Even the real trade now it's like 90 something percent automated. And this will.
We already had a bot problem. Now we have AI bot. That's awesome.
Yeah, exactly. But I can help. I can help on many other things. I believe copyright infringement and other stuff, it's going to be a thing. And AI is the only place where you can have some good ideas to do it.
Got it. Maybe we can quickly make a transition into probably our favorite topics, which is ZK Login. So ZK Login was a project that, of course, I'll let you give a high-level introduction of it, but also want you to dig into what made ZK Login uniquely possible in 2023, 24. Like, why didn't we do this before? Like, what changed?
That's a great question. Deepak, right? Deepak is the guy, our employee, that he helped you as well with some advices on how to have like Reclaim protocol to be on the top of innovation. We discussed a lot with Deepak, but to tell you the truth, even from Facebook, we were looking for ideas how to replace mnemonics, because the average person, as I explained before, that is using the social networks, it's impossible to have a good management of the wallet. We've seen even at Facebook, many people losing their passwords. It cannot work. So we needed another way. And we had one of the best cryptographers in the world, and pretty much on the KYC stage, where when we published the K-Login, he turned to Deepak and he said, how come we haven't thought of this idea before? It's crazy. I mean, the trick was there, but nobody has seen it until we do it. And I was very proud about this, because when Deepak mentioned to me, Kostas, this is what I heard yesterday, I was super happy, because that's the reality, right? And then I came back and I said, okay, what made us actually think about it today? Two things. First, there is an evolution of the ZK algorithms on the performance speed. When you have an authentication system, again, I will use the Facebook story that I'm coming from. You cannot log in and wait 10 minutes to produce a proof, right? Game over, you will lose your user. We had to go into a state, and there with Deepak, we invested a lot of time to have the number of complexity in the zero knowledge proof circuit to be such, in our case, it's about 1 million gates, that you can produce a proof in less than 1-2 seconds. Otherwise, you're losing your users. And it was the time in 2023 that a few zero knowledge proof algorithms and software was at the stage where this was possible now. And with some tricks that we did on getting a Google response, log in with Google, and then automatically you have an account on the blockchain. This is what the ZK login story is, with privacy. Not even Google knows what is your account. We managed to get this output from Google, compress it in a way that you can prove it without revealing anything in less than 1-2 seconds. This was the major advancement here. And making all of this compression, as I explained before, with internetless, requires people with very hard knowledge of tricks you can do in the cryptography space. And imagine we build a team, 40, 50 people working now in Mr. Labs are coming from Facebook, Google, Apple, Netflix, Microsoft. You cannot do these things without having all of this brains together. And we sat down together. The inspiration, by the way, was in Mexico when I went to a trip, and then I had some problems. I was the only Greek person. All of the other Americans passing the borders, they checked my passport more times, and then I said, we need a way to get a passport to enter places or to enter a blockchain. And then they forgot to give me a cookie. They gave to everybody a cookie in the restaurant that we sat. And then where is my cookie? Right? Oh, I need the cookie. I need the passport. And then on the late evening, they didn't give me salt. And then I said, I need also a salt, cookie, and passport. Let's see how we can do it, all of this in zero knowledge. And eventually I managed to create zero knowledge login with Deepak. And all the other things like Arnab, Zoe, Jonas, all of the team that is now working on this. Imagine an inspiration coming from virtual experience on real life, passports and cookies, and the fact that the software is now ready to do it was the way why this happened in 2023. It was not possible in 2020, 2021.
Got it. Just to also make this a little bit more specific, do you have your favorite ZK algorithms, protocols, or software that you think really changed the game in the last couple of years?
Yeah. Look, there are a few different protocols someone can use now in today's zero knowledge proofs. There is the algorithm that is called growth 16, and growth 16 has a huge benefit that is very short. The proof itself is literally all one. Whatever complexity you have, it's the same proof. You needed this in login. Why? Because most of the protocols that are using zero knowledge in the blockchain now, they don't do it for privacy. They do it for compression. They literally aggregate on the L2 level, they aggregate transaction, and then they execute them on the layer one, literally as an aggregator, accumulator of data, that you have a proof that something happened on another blockchain, on another L2. But this is not privacy related, right? And the aggregation there, the importance of aggregation is very important. But for logins, you cannot have the users to cooperate between each other. I will do login now. Are you also doing login? And are you also doing login? Let's together come and aggregate our proofs and put it. Everyone is acting independently. So for things that you don't need necessarily aggregation, as this one, people are acting alone. You needed a system that is very short because it's authenticator. Every transaction will require zero knowledge proof. Some blockchains cannot even accept it, right? You need a very fast blockchain for this. It's something I forgot to mention before. If our blockchain was not that fast, this login wouldn't happen. It wouldn't be possible. You need a scalable system that you can even have very fast computations, and we have some speed records on verifying growth 16. We got ArcWorks, and we managed to make some changes to be able to work with BLST, like Blast, the algorithm, the protocol, the software. And without this, it wouldn't be possible to maintain the TPS that we have today. So you needed also the engineering excellence to make this happen. So growth 16 is one of the algorithms that we invested a lot, and we managed to have some very reputable people participating in the ceremony and all of this stuff. And we made it, and now it's super fast. In 1-2 seconds, it works. The other systems are systems that are offering the aggregator, elements that I told you, or they offer some folding solutions, literally compressing the way you're doing the proofs. But we didn't need it for this particular project. For other projects, however, they're very important because they're probably more complex. Imagine if you want to prove the output of Llama 2 on the blockchain, you need to have some capabilities of doing this really fast, right? If you cannot do that, then eventually you cannot offer fast computation of LLMs onto the blockchain. So they're using other algorithms, typically Starks, Ligero, and this kind of stuff. And there is Plonk, there is Halo2, Zcash, what they're doing, because there it's also a situation where you have to have full confidential transactions. We had to take all of this into account. And by the time we got all of this into account, we decided to use this protocol for ZK login, something else for confidential transactions. It might be bulletproof, for example, or something else if we want to do aggregation. A promise that I give even to our community is probably Sui will support multiple algorithms in the near future, because that's the way to do. You cannot just live with one of the protocols. By the way, in 3-4 days, I'm presenting some cool ideas in the ZK Proof conference happening in Berlin. And I will also make an announcement of some cool things that we're working again on authentication. Literally changing the perspective of, can I use growth 16 for a few other things? Yes, you can, and you will see why growth 16 is not dead. And you will also see where you can use other systems based on the requirement. Different requirements, to sum up, are requiring different algorithms. That's my take here.
Hey, that is super, super detailed. Thank you so much. I'm sure that's very, very helpful. Not only to me, but also to a lot of people in the audience. Of course, it's there's one more raging debate that I want your opinion on. Is I know you mentioned that you're working on some Sui enclaves. I want you to shine a little bit of light on what is interesting about PEEs and what's your take on the debate between, the security guarantees of TEEs versus zero knowledge proofs, and how should one think about that dichotomy?
Okay, you're asking the good person now, because in the first zero knowledge proof conference, I was the one, before I joined Facebook, that I used to work on secure enclaves. And I was in an audience where 150 people were doing zero knowledge proof, and I was the only one with a TE back then. It was a very awkward situation, but it happened. But I have knowledge because I personally implemented stuff on SGX. I literally ran the whole Java virtual machine on SGX. This was one of my jobs in my previous company. So I can compare the two of them. What I realized is there are applications where you don't care about the long-term security of TE. I don't know if you can also imagine a few of them, but I will give you a few examples. One of them is MEV protection. Why do you need MEV protection? Because sometimes you want to submit an order, let's assume for a swap, and you don't want other people to see your transaction before it's executed. However, if you have like an enclave system, you only need this to be secure for just a few seconds. And after the execution, that you already have your transaction being on chain and nobody could see it and all of this stuff, you don't care anymore about privacy in some situations. You only want it to protect against MEV attacks. So there is a situation where if there is a problem with SGX or TE, in these applications, it makes sense to use this that is super fast because you need fast execution on trading. This is very important on high frequency trading, and zero knowledge proofs or even MPC, they cannot go to these speeds that the TE can offer. And you also need it for a short period of time. You need an update, you make the update. I mean, if there is a microcode update because we found something that might be vulnerable, you don't care about the past. You only care about the future. So there are applications like these for which enclaves are really good. I wouldn't use at the moment, well, under certain requirements from regulators, maybe I would do it, but at the moment, as I am as a researcher, I wouldn't use it for long-term secrets. That I agree. But there are other applications like poker shuffling. Poker shuffling, it's only for one game. You're finishing the game in 20 seconds. And it's okay if something breaks in the future. It doesn't change the outcome of the past. So there are applications where literally you can do with secure enclaves if you have to do with short-term encryption of data, mostly for purpose of front running and learning information that is important at the time of this happening, and you don't care if an attack happens in the future. This is my take. For everything else, I would use zero knowledge proofs.
Got it. I think that is the most tactical advice that I have heard. Thanks for that mental model. That's super useful.
Do you agree that for something that is very short term, it's okay, right? I mean, to have an attack in 1 second for someone to exploit that attack is impossible, right? So it's okay. You will do the update on the microcode and you will continue from there.
Good. Yeah. That's actually. I'm not able to. Make any holes on this in real time, but broadly, it feels like something that I agree with, because only when you need long-term security is when you use zero knowledge proofs in the first place. And also, to go back to your previous point that you were mentioning, another place to use zero knowledge proofs is probably when you want compression, right? So because these are much shorter proofs, you can use it for scalability, and it's just reducing the size of the proofs itself. But TEs are really good when you need high speeds and you need privacy only for a limited amount of time.
Exactly.
This is kind of really.
This is when science. This is where TEs can actually be a very good substitute of zero knowledge proofs and MPC.
Got it. And the question that follows from that is, what is something that is most misunderstood about zero knowledge proofs? What is something that you see regularly that developers or other researchers are getting wrong about zero knowledge proof that we should set right using this podcast?
Okay, that's a great question. I will start with the assumption that I've seen a few papers that generically say, I will do this with zero knowledge proofs. If you don't sit down and implement it, you will realize that it's not like one day you're sitting down and you're having, I'm having a patent that I'm using zero knowledge proofs to solve this. Well, the reality is vastly different. The problem, however, is on the fact that we don't have good standards. There is a plethora of algorithms at the moment, and people don't know which one to use. And there is even startups, and because the innovation rate in general in the space due to the blockchain, because the blockchain brought money to cryptography. Let's be honest, right? This is what happened. And the reason that you see so many advances in cryptography lately compared to the RSA and TCDSA and TDDSA that we had in the past is because funds actually wanted to use the blockchain technology, and indirectly, as a domino effect, the cryptography spectrum was exploded. And however, when you are having all of this fast traction here, it's very difficult that you start with one algorithm and you say, in 6 months, Starks will be a lot faster. And now I have to switch to Starks because otherwise I'm out of the competition. So you need to come up with a schedule of updates, and we have to actually accept what is the current situation, because otherwise you will never go out to business. If you don't start implementing things and you say, 1 year I will use the other system, but there is no ID for this system, there is no good developer experience, which means that the average banker engineer or a bachelor student, they cannot use it, and now you don't have audience. So I believe we're getting into a more mature state where some of the previous algorithms will start to be mainstream. And only when you want to be also a high-pace innovation company where this is very important for you to be on the top of the competition, to use the new algorithms. But even there, the whole community is lacking good systems for writing code in ZK. People are not familiar with it. They believe they can do it in one day, but believe me, we're staying with Deepak and we're making optimization of ZK login, and you need actually to go and buy Burger King and something else because otherwise you're running out of sugar. Right? You have to be in a situation where you have to understand which algorithm you want to use and also spend some time to educate yourself on what is possible. People don't know what is possible with ZK. Not everything is possible. If you want to have like AI and someone says, oh, with ZK, I will verify the output of AI, maybe you need 20 minutes now to do it. Can you like work with that? If you don't try it, you don't know. And there are not so many developers. If I was about to, I don't know, advise people, what should they do on the PhD? The future of cryptography is 3-4 things: zero knowledge, multi-party computation, fully homomorphic encryption, and in my opinion, all of the rest are going to be either replaced by these three technologies, or you have to be like very smart to create concrete schemes that surpass the speed of these generic schemes, but in the future they will be dwarfed again. So these are the three topics I would personally invest if I was 20 years old.
Got it. Wow. Okay. So you think the future of cryptography itself is ZK, MPC, and FHE?
Yes,
Got it.
that's what I believe.
Understood. And what I also liked about your advice over here is for startups always to, kind of reevaluate what is the technology out there and always try to be up to date with what is happening. Otherwise, we'll just get beaten out by competition because maybe you implemented something today. In 6 months, that's outdated.
This is true. I do agree with you, but there is a sort like a bar that you have to meet. If you always are thinking about it, you never start. So you have to eventually cross the bar somewhere and say, look, I cannot wait for 6 months until the next system comes. I need to prepare my team to be ready to switch afterwards. But I have to implement it. If you don't implement it, then you don't have a startup.
Exactly. I think the reason that resonates with me is because we are in exactly that kind of a situation right now in which we've already implemented Grot 16. It's out there. People are using it. It's out in production. But now we always need to figure out, hey, okay, fine. Grot 16 is giving us, let's say, proofs in 4 or 5 seconds. But how can we do better? Right. So that's a question that we've started asking now, probably after 1.5-2 years since we first implemented Grot 16. So yeah, I agree with you. It's important for us to like just run with something that's already out there, and but also have an eye out, saying, hey, what's improving all the time.
And there is also the risk of the new technology having some bugs, right? You remember the first paper from the Nova system? There was a bug there, right? So it's not that you can go directly. I mean, if you have a mature company that is offering zero knowledge proofs to the industry, you cannot easily jump just because something is faster until you do a proper review, right? And you leave the community some time to actually explore it. It's also this problem, right? Maybe some startups can take more risks, and then eventually it's a balance between the risk and how fast you want to move, all of the things. And I believe that different startups have different pace. Even culturally wise. I mean, if you are in Europe, maybe you go slow. If you're in the US, maybe you have to move really fast. If you are in Asia, you go even faster.
Got it. Interesting that you mentioned cultures associated with geographies. That's so interesting. Last question, Kostas. I know you've been shooting insight after insight for the last 40 minutes, but I want you to do that one more time. What are some problems that you wish developers paid more attention to in the blockchain space in general?
That's a good question. Look, in my opinion, like as a company, I will reply as a company first on what I would like to see. Many engineers who are coming from different industries, they don't educate themselves really well on the consensus algorithms and other things that are very important to jump in very quickly to the protocol. But this is to build an L1 and L2 and others. It's very difficult to find this skill set. I also realized on the cryptography space that there is a big gap between theoreticians and people who are practical to implement stuff in a fast way. Cryptographers many times are coming from mathematical background. They are not like hardcore engineers during their like early days, where this helps actually for the synapses and a lot of other things happening in your brain. And at the same time, software engineers are not very good at like very advanced math, because you need sometimes a PhD to be able to understand these things. There is a small set of people who can implement this stuff. I personally find it very difficult to find developers who have the mindset from both of them. So someone who is a theoretician and is able to also code stuff. Because otherwise you have a broken phone in the situation where the theoretician is telling you do something and you cannot do. One of the reasons that only very recently we managed to have zero knowledge proofs being faster and being implemented in parallel environments is only after the developers managed to get the expertise on the existing systems, even grow 16 understanding them, and then being able to actually make them better. The most difficult skill, in my opinion, to find at the moment is someone who knows very good zero knowledge proofs on like micro optimizations, and then they can go further and build something new on the zero knowledge proof space. This is a very difficult skill. It might not be even possible to find it in one person, but the more people you add in the in the flow, the more difficult it is to be able to have something that works. This is the most difficult skill to find, in my opinion, in the space at the moment. Like some education either on consensus or cryptography, but being a very strong engineer. Do you have this person in your company? We do have a few, right? We do have a few, and that's why we're innovating a lot. Without this, I don't. Right. Sometimes you might have great ideas, but if you are a professor in the university, you don't have time or you don't have the skills to implement it.
That is true. I think very, very rare talent indeed. I actually, now that you asked the question, Kirill from our team, who is closest to what you're mentioning, is right here on this call as well. So I'm super excited.
You will never, you will never have a problem in your life, whoever you are.
Yes. Yes. So, Kostas, this has been some serious hitting. I'm super thankful, super grateful that you've taken time today, not only to speak with us and share your knowledge, but also thankful for all the advice that you've given us to grow in the last several months that we've been working together. Very excited to be live on Sui. Now we in fact just got the audit done as well, so that's going to go out. And we're going to be starting onboarding a lot of Sui developers on Reclaim Protocol. So very excited to be working together here, Kostas. And thank you so much once more for coming here for this candid conversation.
Likewise, and my pleasure, and happy to, whenever you want Deepak or myself for like small advices, everyone who is building on Sui is, I'm also an advisor of them, if you want, for free. I'm super excited, especially if you're doing like hardcore stuff like zero knowledge proof and AI, which is like pretty much my domains. I would love to help. Even to our listeners here, I live for this, right? Imagine, I forgot to mention this, but my son's name is Kryptos. Imagine someone who named his son Kryptos, right? So obviously I'm all in this space, personally. And the most difficult challenge in my life was not to find an algorithm, was to convince my wife for this name. Anyway, I loved it, and thank you so much for inviting me. I really appreciate your work you're doing, and good luck.
Thank you so much, Kostas, and good luck to you as well. Thank you so much, everybody, for joining in. Have a great day ahead. Bye-bye.